A student carries out an electrolysis experiment using the apparatus shown. Okay, so you can see there's an electrolysis using carbon electrodes, wire, and they have taken dilute aqueous sodium chloride. The student uses dilute aqueous sodium chloride. Okay, so that is NaCl, aqueous. State the name given to any solution which undergoes electrolysis. We know that that solution is known as electrolyte. So answer for this question will be electrolyte. Electrolyte, yeah. Now hydroxide ions are discharged at the anode. Complete the ionic half equation for this reaction. Okay, so we know that hydroxide ion is OH minus ion, and whenever the hydroxide ions are discharged, they releases water and oxygen, H2O. So we write H2O over here, and now balancing it, since there are 4 electrons, so we write 4 over here. Hydrogen is 4, so we write 2 over here, hydrogen, and oxygen is also balanced, oxygen is also 4. So this is the complete answer. Yeah. Explain how the ionic half equation shows the hydroxide ions are being oxidized. So we see they are losing these 4 electrons. So hydroxide ions are actually losing the electron. So we write hydroxide ion loses electrons. As you can see, these 4e minus electrons they loses. And students, to score good grades and to watch our latest videos, please subscribe and press the notification bell icon to all. Thank you. Now, C part. Describe what the student observes at the cathode. So see, at cathode is basically negative electrode. So see, first of all, let's see. So this is cathode and this is anode. Yeah. Cathode is negative, anode is positive. Now, what are the ions? So ions, we have Na plus, Cl minus, and OH, so ion H plus, and OH minus ions. Okay, so at cathode, we know that cathode is negative, so the positive ions will be attracted. So they are Na plus and H plus. Now see, Na is very strong, so it will remain in its solution. So it is the H plus which is going to be reduced. So H plus, it takes an electron to form hydrogen atom. Hydrogen atom reacts with combines with another hydrogen atom to form hydrogen molecule, because hydrogen atom cannot exist independently. So basically hydrogen is released. Now see, but hydrogen is colorless. So you have to write what he observes at the cathode. So basically what he observes is fizzing. 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 Fizzing at the cathode. Write the ionic half equation for the reaction at the cathode. So see, basically at the cathode, the H plus ions, they actually takes up electron ions and form H. So since H is H2, so we write 2 over here, 2 over here to balance it. The student repeats the experiment using concentrated aqueous sodium chloride. Now see, it is concentrated now. It's concentrated, aqueous sodium chloride. Describe what the student observes at cathode. See, at cathode, there is no such change. It will remain the same. So it's basically what he'll see is the fizzing. But at anode, now there are changes at the anode. Why? It's because of concentrated aqueous sodium chloride. Now see, anode is positively charged. So 2 negative ions which will be deposited are Cl minus and OH minus ion. But in this case, it's concentrated. So Cl minus ion concentration is more. Hence, chlorine will be observed at that electrode. So chlorine will go to the anode. It will be oxidized. Chlorine, it loses the electron. It gives the electron to anode. Basically, it is oxidized. Chlorine atom doesn't exist independently. It forms chlorine molecule. Cl plus Cl, it forms chlorine molecule. But we have to write the observation. Since chlorine is green gas, so what we will write green gas is because of the release of chlorine. Okay. The student added litmus to the solution after the electrolysis of concentrated aqueous sodium chloride. Okay. State the color seen in the solution. Give a reason for your answer. It is concentrated aqueous sodium chloride. So what will be the color of the solution? Now see, first of all, writing all the ions. Na plus Cl minus H plus OH minus ions. Now during the electrolysis, these two are actually used up. Now what is left? Na plus and OH minus ions means sodium hydroxide is left. So this is NaOH, which is alkali, So what you will write? The red litmus turns red litmus blue. And the reason, because NaOH is alkali. NaOH, sodium hydroxide, which is the base, or you can write alkali, is formed. That's why it turns red litmus to blue. Carbon electrodes are used because they are inert. State another element that can be used instead of carbon. So see, we know that platinum is also inert, so we can also use platinum electrode. So our answer is platinum. This question is about compound of nitrogen. Nitrogen reacts with lithium to form lithium nitride, Li3N. Write the chemical equation for the reaction between lithium and nitrogen. We know that lithium is Li plus and nitrogen is N3 minus. N3 minus. Yeah. So now writing the chemical equation, it forms react with Li plus nitrogen, which is N2. It forms Li3N. Li3N. Now see, first of all, balancing nitrogen. So we write here 2, but lithium becomes 6. 2 into 3 is 6. So we write 6 in front of the lithium. So this is the complete balanced reaction. Okay. Lithium nitride is ionically bonded. Okay. Complete the diagram to show the electron structure of the nitride ion. Show the charge on the nitride ion. We know that the charge on the nitride ion is 3 minus. So first of all, writing the electronic configuration of nitrogen, which is 2, 5. So it has 5 outermost electron and it actually gains 3 electron to form N3 minus. So this will be 2, 8. So this will be the complete structure of N3 minus 2, 8. So we write 3 minus here first of all, and then we will make a shell. Okay. Now cross will represent the nitrogen ions, so which are 5. So we write 5 crosses over here, and borrowed ones we represent by the dots. So we make 3 dots over here, which shows these are the borrowed ions, because of which it is 3 minus. So hence this is the complete electron dot structure. Now B part. Nitrogen reacts with fluorine to form nitrogen trifluoride, NF3. The chemical reaction can be represented as shown. N triple bond N plus 3F single bond F. It forms nitrogen trifluoride. As you see, 2 molecules of nitrogen trifluoride. Now, some bond energies are shown in the table. This is for nitrogen, fluorine, fluorine and nitrogen, fluorine that are given. Okay. Calculate the energy change for the reaction between nitrogen and fluorine using the following steps. Energy taken in to break bonds. So see, energy taken in to break bonds, this is nitrogen. It is 1. So we write 1 into 945 from the table. And then you have 3 fluorine, fluorine. So that will be plus 3 into 160 from the table. So this totals up to 1425. 1425 kilojoule. 25 kilojoule. Okay, so energy taken into break bonds is 1425. Where, so we write plus over here because it's taken in, so breaking bond energy, so it is endothermic. Energy released when the bonds are formed. Now see, NF is 300, so here are 2. So, and there are 3 NF bonding actually. So 2 into 3 into 300, which is equals to 1800. So this is the amount of energy released. Energy released when the bonds are formed will be minus 1800 because the energy is released is by minus. Now energy change during the reaction. So total energy change will be plus 1425 minus 1800. So that will give you minus 375. So plus 1425 minus 1800 is minus 375. So here minus sign means the energy is being released. So minus 375 kilojoule per mole. Use your answer to 1 to deduce whether the reaction is endothermic or exothermic. Explain your answer. As we can see the minus sign. The minus sign represents the energy being released. And when the energy is released, so that is an exothermic reaction. So it is an exothermic reaction. As you can see, it's minus 375. Energy is released. Now, complete the dot and cross diagram to show the electron arrangement in a molecule of NF3. Use dots for nitrogen electron and crosses for fluorine electrons. Show outer electrons only. So we know that a nitrogen has 5 outermost electrons. So dots for nitrogen. So see, and crosses for fluorine. Okay. So see. Now see, nitrogen has 2,5 electronic configuration. It has 5 outermost electron, which will be represented by dots. So 2 electrons which don't take part in the reaction, and we write 3 electrons like this, which is taking part in the reaction or in the bond formation. Fluorine is 2,7 and we represent it by the cross. So it has 7 electrons in the outermost shell and is represented by the cross. So now writing for the fluorine 1, 2, 3, 4, 5, 6, and the 7th electron is being bonded up. Similarly 1, 2, 3, 4, 5, 6, 7th electron bonded up. Again 1, 2, 3, 4, 5, 6, 7 electron being bonded up. So this is the complete electron dot structure. Now lithium nitride melts at 813 degrees Celsius. Nitrogen trifluoride melts at minus 206. Explain in terms of attractive forces why lithium nitride has a much higher melting point than nitrogen trifluoride. In your answer, refer to the types of attractive forces between the particles and their relative strength. So see, we know that lithium nitride is made up of ions. So what you will write is lithium nitride has a strong ionic bonding. Has strong ionic bonding. The force of attraction, ionic bonding, is basically the force between the ions. So the force of attraction between its ion, like Li3 plus and N3 minus ions, is very strong. So hence, very strong attractive forces between ions. Nitrogen trifluoride has a covalent bond. You can see there was a sharing between its molecules. So nitrogen trifluoride has a covalent bond between the molecule. Nitrogen trifluoride has covalent bond between molecules which is much weaker than the ionic bond. Which is much weaker than the ionic bond. Hence, lithium nitride has a very high melting point as compared to nitrogen trifluoride. Okay, next one. D part. Ammonium nitrate NH4NO3 is a compound of nitrogen. Okay, calculate the percentage by mass of nitrogen in ammonium nitrate. So see, first of all, calculating the molecular weight of ammonium nitrate. First of all, I write the atomic masses of all the atoms which are present. Nitrogen is 14, hydrogen is 1, oxygen is 16. Oxygen is 16. So calculating the molecular weight of ammonium nitrate, so that will be, there are 2 nitrogen, so 2 into 14 plus 4 hydrogen, 4 into 1 plus 3 oxygen, 16 into 3. So that comes out to be 80. Okay, we have to calculate for nitrogen. There are 2 nitrogen atoms, so 2 into 14 is 28. So to calculate the percentage, this will be 28 by 80 into 100. So 28 by 80 into 100 is 35%. So the percentage of nitrogen is 35. State a use of ammonium nitrate in agriculture. We know that is used as a fertilizer. So ammonium nitrate is used as a fertilizer. What we will write? Fertilizer. Fertilizer. Okay. State the name of compound that will displace ammonia from ammonium nitrate. So see, any strong base can displace ammonia from ammonium nitrate. So that could be potassium hydroxide, calcium hydroxide, or barium hydroxide. So I am writing calcium hydroxide. So you can write the any strong base. So I am writing the calcium hydroxide. Okay. Ammonia is a base which forms weakly alkaline solution when dissolved in water. Define the term base. So basically base is what? Base is proton acceptor. Base is proton acceptor. And you know that acid is a proton donor. So see, this is an important part of IGCSE. Says what is a base and an acid. So base, you should know, is a proton acceptor. And acid is proton donor. Proton donor. Yeah. Suggest the pH of aqueous ammonia. Now see, this is weakly alkaline solution. So you can write it lies between, it is greater than 7, less than equals to 11. You can write 10 also. That is also a correct answer.